Good morning. Today I will discuss a small topic. This is the excess pressure. Okay. First, here I will discuss the surface tension. What is the surface tension here? Surface tension is the property of a liquids. Okay. Due to this property, the liquid surface always tries to maintain its surface area minimum. Okay. That already we know, and also we know how to find the surface tension. Okay. But now in this class, I will discuss the excess pressure here. What is the excess pressure? Excess pressure means this is the pressure difference. Okay, pressure difference between two surface, between any surface. Okay, we consider this is the surface A, B, C, D. Okay, and there are two pressure is there, upward pressure and another is downward pressure. Okay, and here the upward pressure is P1 and downward pressure is P2. So if both pressure is same, if both pressure are same here, then the surface is always in a plane. But this surface is a curved plane. That's mean we can say there have a pressure difference between the surface ABCD. Okay. So here we find the pressure difference here, and that is called the excess pressure here. So we consider this is the A, B, C, D. This is the plane and this is the curved plane. Okay. And here the downward pressure, suppose we consider the downward pressure is P1 and this is the upward pressure which acts on this. This is the P2 here. Okay. And here we can say P1 which is greater than P2. Okay. That's why the surface become curved here. Suppose we consider this is a plane here. One pressure which acts along this direction, another pressure acts along this direction. If two pressures are same, then we can say the surface is a plane surface. But suppose we consider this is the P1 and this is the P2, and now the pressure, this P1 is more greater than the P2, then you can say the surface become that type. This is the curved surface. Okay. So if the surface is curved, then we can say here P1 which is greater than P2 here. Okay. And our topic is the excess pressure. Excess pressure means that is the pressure difference here. So initially we consider the plane A, B, C, D. Okay. And now we can say due to the excess pressure, the surface become increased here. When the surface become increased, after that the surface become A dash, B dash, C dash, okay, and D dash. Okay, and here we consider the length of the AD. This length is x. Okay, and after that, when the surface is increased, then the length which is become x plus dx here. So you can say here the AD, the length is x, and after that the length which become A dash d dash, we consider this is x plus del x. Clear? And next, we can say this is the length and the breadth. Initial the breadth which is DC, which is y, and after that the length become d dash c dash, and which is y plus del y here. Okay, so from here we can say the initial surface area of the thin film, this one, x into y. Okay, and after that the final surface area, when excess pressure acts on the thin film, then the area is increased. Okay, and after that the final surface area which is x plus del x into y plus del y. Okay, so here you can say this one is xy plus x into del y plus y into del x, and this is del x into del y. And now see here, the del x and del y both is a very small term, so that's why we neglect that term. Okay, so finally we get here this is xy plus x del y plus y into del x. Okay, see, this is the initial surface area. That's means the surface area of the plane A, D, C, B. Okay, and after that when excess pressure acts on it, then the surface become A dash, B dash, C dash and D dash. Clear? So here we can say how much surface area is increased. Now I will find how much surface area is increased here. So you can say that increasing surface area, if we consider this is delta A, then what is the delta area? Final surface area minus initial surface area. So final surface area, which one? Xy plus x dy plus y into dx. Okay, minus, I will do the initial surface area, that's one xy. So xy cancel here. So delta A, which one? Delta A, which is x into dy plus y into dx. This is the changing surface area. See, first of all we consider a plane, thin film. Okay, when excess pressure act on it, then how much surface area is increased here? The surface area which increased, this is x dy plus y into dx. Okay, when surface area is increased here, then we can say the potential energy which is changed here, energy is changed here. So see, initially the thin film, they have a surface tension. So here we find the energy by the help of the surface tension, and also we find the surface energy by the help of Newtonian mechanics. Okay, so first I will find the surface energy due to the increasing surface area. Okay, and due to the surface tension. Okay, so first now I will find the surface energy. Okay, so now I will find the surface energy. Therefore, the surface energy which equals to, we know the surface energy means surface tension into changing area. So we consider the surface tension of the thin film is T. Then we can say T into delta E. Delta is the changing area here. So that one T into x dy plus y into dx. Okay, so this is the surface energy. Why the surface energy is produced? Because the surface area is increased due to the surface tension. That's it. Okay, so first here we find the surface energy. Okay, and this is the one method, and another method, and we find the surface energy. See, so another method is that the surface energy is that another method, the surface energy, that is the work done by the excess pressure. That's what we can say here, the work done. This is equivalent to the work done here. So what is the work done? This is force into displacement. So suppose consider the force is F into displacement. That's when displacement means here we consider this displacement which is d to d dash. Okay, so here the displacement here d dash, and we consider this is the delta r. This is the displacement here. This is we consider d dash, which one is delta r here. Okay, so you can say this is delta into r. Clear? So now see how we can find the surface energy in this method. So here we can say the force means the force which is produced due to the excess pressure. Okay, so we know the excess pressure. We consider this is the delta P. Okay, we consider it, the excess pressure is delta P, and due to the excess pressure the area is increased here. So delta P into, okay, if this is an excess pressure, then we can say this is delta P into pressure means, you know, pressure is equal to force divided by area. Okay, so you can say force is equal to pressure into area. So delta P into area. Area means here x into y. This is the initial surface area into delta r here. Okay, so sorry, this is the area. X into y means this is area, and then be the excess pressure, and this is the displacement. Okay, so both are same here. The surface energy, and both cases the surface energy is same here. So we can write P into x dy plus y into dx. That is equal to, you can write this is delta P x y into delta r here. Okay, so delta, what is the delta? Delta means here, this is the displacement of the thin film here. And now see, now here there are two variables are there. This is, one is x, another is y. There are two variables is there. Okay, now we change the variable in a single term. Okay, that's why see here we consider the triangle. If this point is O and this is the O dash. See here, this is a curved path. Okay, and its radius of curvature is r1. This is the length. Okay, and this one is breadth, and its radius of curvature, suppose consider this is the r2 here. Okay, so r1 is the radius of curvature. That's mean the initial radius of curvature of the length, and r2, this is the radius of curvature of the breadth, and this is the initial radius of curvature. Okay, and see here we can say here from the triangle of ADO. Okay, this is the triangle of ADO, and in this triangle we can say here, according to triangle law, ADC and triangle of A dash D dash O. From this two triangle we can write here R1. Okay, R1 means this distance. Okay, so R1 divided by, and this one is x. So that one we can write R1, and this length is delta R plus delta R. Okay, when we write the R1 divided by x, then we can write, and that one is x plus del x here. Okay. And also according to mathematics we can write, and this one is del r divided by del x. Also you can write this one is del r into del x here. Okay, so from here we can find the value of this del x here. So now we can find this value of del x. So we can write del x that equals to, which one is r1 and x into del r. Okay, so from here, from this triangle of A over D and triangle of A dash, D dash and O, we can write del x equals to x divided by r1 into del r. Okay, and another triangle here, this is triangle of O dash, D, C and triangle of O dash, D dash and C dash. From this triangle, we can find del y, which one? Y divided by r2 into del r. Okay, so now here I will put this value del x and del y. See, this one is del x. So we can write t into x into del y. Del y means y divided by r2 into del r plus y into del x. Del x means x divided by r1 into del r. So that one is del p, that's an x spacer, into xy into del r. So here we take the common here, and if we take the common xy, then we get t into xy. We take the common xy, then we get 1 by r1 plus 1 by r2 into delta r. That equals to del p into xy into delta r. See here xy, both sides is cancelled here. Okay, so here you get only the 1 by r1 plus 1 by r2 into delta, and delta which is also cancelled here. So from here finally we get the value of the x spacer, that is del p, which will be into 1 by r1 plus 1 by r2. So this is the general formula to find the x spacer. So see here, here we consider a random thin film that have no any particular shape, but here due to the x spacer area is increased. Okay, now we see the example for different cases, and we apply this formula and we find the x spacer for different cases. Okay, first case, see here, example number 1, see. So this is example number 1. We consider a air bubble. This is an air bubble. Okay, so see here, this is an air bubble. This is example number 1. An air bubble here, the inner surface is air and outer is also air. Both are air here. So here, what is the x spacer? See, if we consider a elementary portion, only air bubble, and there the radius of curvature, length and breadth both are same, and both are the radius of the sphere. So that's why you can write here the x spacer del p, which is equals to t. Here the two surfaces there, that's why we consider this is 2t, and here r1 and r2, and both are same. Here r1 and r2, that is equal to r. Why r1 and r2 are same? This is for elementary surface, okay? And if we consider the elementary surface on the sphere, then we can say there r1 and r2 both are same and both are equivalent to smaller. This is the radius of the sphere. So del p, here we get 2t into 1 by r plus 1 by r. So that one we can say this is 4t by r. Okay. So and what is the direction of the x spacer? You see the direction of the x spacer along this direction. If the inner spacer is more compared to the outer spacer, then the shape becomes the sphere. Okay. Now next, see the another example. Example number 2. See. Example number 2. See. If this is an, suppose consider this is a water drop. This is a water drop or any liquid drop. Okay. Water drop means there have inner is a liquid is there. Totally liquid was there. There only one surface, and this is the air medium is there in the air medium. Okay. And what is the direction of the x spacer, which is along this direction? So for that case, how can find the x spacer from this formula? Okay. See here, del p that equals to, here the only one surface is there, so we can consider this is the t. Okay. And into here the radius of curvature both are same thing, 1 by r plus 1 by r. So this is 2t by r. So del p, which one is 2t divided by r. Okay, this is the example number 2 here. See another example, example number 3. Example number 3. If we consider this is a cylindrical liquid drop, this is a cylindrical liquid drop. See, if we consider the elementary surface on this liquid drop, then we can say the radius of curvature, which one, r1, this is the radius of the cylinder, okay, and r2, which is the straight line, and we know if they have a straight line, then its radius of curvature which is infinite here. So we can write the excess pressure del P, which is T into 1 by R plus 1 by infinity here. So here we can write del P is equal to T by R here. Okay. Next example here, example number 4c. So this is the general formula. From this formula we can say we can find the excess pressure for any cases. See another formula. This is example number 4. See, this is a liquid is there. Okay, in this liquid there are one sphere is there. Okay, this is a basically suppose consider this is an air bubble in the liquid here, and its radius suppose consider r. Okay, then what is the excess pressure? Then del P we can write this one is T. Only one surface is there because there have a liquid, and in the sphere there air is there. So here only one surface is there. That's why you can write this is del P is equal to T, but here 1 by r plus 1 by r. So we can write this is T divided by 2r. This is the value of the excess pressure. Okay, and now see here. And here one thing is that is distance is h here. So that's why we also added the pressure due to the atmospheric pressure. Not here atmospheric pressure is there, but there have a liquid pressure is also there. So this is rho gh. So the value of the excess pressure, which one is del P is equal to T by 2r plus rho gh. Okay. And next example, example number 5c. Here we consider this is a container, okay, and a liquid is there, and this is the shape of the liquid, and its radius. If the shape is the concave meniscus, the meniscus is here concave meniscus, and here suppose the consider its radius is r. Radius of the meniscus suppose consider this one is r. Then here del P equals to, we can write this is only one surface is there. Another surface is liquid is there, only a surface is there, that's mean only one surface. So there are two free surfaces here, only one free surface is there. That's why we can write this is T 2T divided by R here. Okay, if the surface is concave meniscus, suppose the surface is the concave meniscus, for that also we can say the excess pressure which is also 2T by R. Okay, similar same thing is there. So for different cases, and suppose the liquid is there, this is the plane surface, plane meniscus, for that cases, here the excess pressure, that means the upward pressure and downward pressure both are same, so we can say that del P which is become 0. Okay, so from this excess pressure, from this formula T into 1 by R1 plus 1 by R2, from this formula we can find the excess pressure for any cases. Thank you.